Great, so we're going to do a problem where you're in your house and it's going to be, let's say you have it at, 70 degrees. And suddenly the heat goes out. The outside air, let's say it's about 30 degrees. So in our equation, the outside air goes 30 degrees. And you know 1 hour later, it is now 65 degrees in your house. The temp is 65. The question we're going to ask is, what will it be in another hour? The temptation is to think, well, it dropped 5 degrees, so it's going to drop another 5. And that's not terrible. That's an okay approximation. But recall that we've seen that the way the temperature changes will be proportional to the differences. And so originally it's going to drop faster, but then as the temperatures get closer, the speed at which it changes will slow down. So a couple things that we'll need to remember from this one is the original temperature is our T naught. All right, so let's do this in green. We have a T naught was 70. The outside temperature is our M, which is 30. So we were given an equation that sort of solves this pretty quickly. And so we can say, well, the solution for this difference equation is, well, it would be T naught minus M times e to the negative kt plus m. So we have all our values for T naught and M. But in order to find k, we're going to use this value that says 1 hour later, it's 65 degrees. Let's think about this. So let's first plug in the values we know. So we know this one's 70 minus 30 e to the negative kt plus 30. So this is just 40 t plus 30. Now we're going to think, well, what happens that 1 hour later? So t of 1 gives us 40 e to the minus k plus 30, and this is going to be equal to 65. So e to the minus k will equal 35 divided by 40. Or in other words, k would be the negative version of the natural log of 35 over 40. So there's a value. We could get an approximate value if we choose, but right now I'll just keep it exact and say, all right, so then what's it going to be? So then we have all our values. We have everything in our equation that we need. I could write it out. We can do it out maybe in blue and say our equation then for our temperature at any time is 40 e, and so this would be the natural log of 35 over 40 t, right, beautiful number, right, plus 30. And we're just asking, well, what is it going to be when the time is 2 hours later, right? So we waited an hour, it was 65. What about 1 more hour? So we plug in a 2. So let's do this in, let's say, the white. So we thought, well, maybe it'd be about 60 or so, and that's a fine approximation. And because we're still a bit a ways from the 30 degrees, it'll be even more accurate. As we get closer and closer, that sort of approximation will not be as good. If you sort of think about it, maybe in an extreme case, if we waited, if we said something like a few hours later we were all the way down to 40 degrees, if we kept trying to do an arithmetic progression like that, we'd end up predicting that our house would get colder than the outside, and that clearly can't happen. All right, and also it looks more, sort of think about an exponential curve. That might be something to think about, because this is basically like an exponential decay, all right, with a constant there. Over here, it looks more linear, so you might think, oh, it seems to be dropping about the same, but then it starts to curve off, and so those sorts of approximations, they work, they're okay for a little bit, and I really could have simplified this even further now that I look at it, just because you have the natural log up top. So let's just go ahead and, while we're talking about it, before I plug it into my calculator, say this T could also have been simplified, if you chose, by doing, let's do it over this way, to the right. Could also be 40 times 35/40 to the power of t plus 30. That's another way of writing this one, which might be easier to plug in, just using some simplifications there. So let me allow me to plug this. So 40, 35 divided by 40 to the power of 2, right, is the example that we're looking at. And if I do that, it's going to give me not 60, right, but 60.625, right? So you weren't very far off, because it is pretty approximate. But then you might think, well, if you keep that approximate up, let's just sort of think about what would happen. You would expect it to be 30 degrees after how many? So 8 hours. Let's plug an 8 into this and sort of see what would it be after 8 hours. Let me zoom out a little bit. This is too zoomed in. So if you waited 8 hours, your temperature, you expect it to be 30. But it would now be, just let me finish this up. After 8 hours, instead of being 30 degrees, you're actually at, closer to 43. So you see, if you're anticipating that it keeps going on that same progression, like so, it's going to be more wrong later on. So this would be sort of like you predicted to be 30 degrees, but it's actually 43 degrees.